Hello everyone. In this video, I would like to introduce Stream API. Um, what is Stream API? Stream API is designed to process collections in functional style. So we know, right? Java supports functional programming by providing certain features like lambda expressions, method references, functional interfaces, and also Stream API. So Stream API is a very powerful feature. Uh, you know, normally in real-time applications, what we do, normally we get the data from the database. Immediately after getting data from database, we will store the data in collections, right? Probably in list or set or map, right? So definitely we'll process those collections. This is very normal, right? So to make it easier to process collections in functional style, because we have certain benefits, right, if we do functional programming. So keeping those points in mind, Java designed this Stream API to make developers life easy. Okay, so streams, what is stream? Normally streams represent a sequence of elements, okay, that support various methods to perform some aggregate operations. Okay, these operations can be chained together to form complex data processing pipelines. The Stream API encourages a more functional programming style by promoting operations such as map, filter, collect, for each, flat map, and many more. So it is providing some methods for us as part of Stream API. Using these methods, we can simplify our programming, our coding also. We will see how we can simplify and how we can quickly write complex logics using these Stream API methods. Normally we will chain all the methods, so the chaining is nothing but pipeline. So in a stream pipeline, how it looks and how it works, we will see. A stream pipeline in Java consists of three main components. So what are those components? We will see. One is source, second one is intermediate operations, and third one is terminal operations. So why we are calling as intermediate operations, terminal operations, source, we will see. What is source? The source represents the data source from which the stream is created. Can you guess what should be the source? Nothing but collection, any list or set or map or arrays from which we can generate the stream, right? Because collections are nothing but collection of objects, right? So from which we will generate the stream, right? So source, what will be the source? Source is nothing but here collections only or arrays. So it could be a collection. So source could be a collection, an array, and an IO channel also, or a generator function also. Okay, this source provides the initial set of elements for processing in the stream. And next, what are intermediate operations? Intermediate operations transform or filter the elements of the stream. So this is the next step. Once we generate the stream, on top of the stream we will apply some methods. We call them as intermediate operations, and using those intermediate operations we will transform or filter, and we can do many more. We will see those. Okay, they are chained together to perform a pipeline. That means they are chained together to form a pipeline. That means in the pipeline means in the first step, that can be transformed to that can be filtered to some even. Let's say I was passing a stream of even numbers, stream of natural numbers. From the natural numbers I can filter for even numbers. After finding the even numbers, I can check for again I can check for some other, like maybe I want to do some, or I want to do some other operations. Continuously we can change the operations actually. That is nothing but pipeline. Okay, each intermediate operation takes a stream as input and produces another stream as output. Remember, intermediate operations, what is the input for intermediate operation? Stream only. And what is the output it will produce? Again stream only, remember. So these are the intermediate operations. Intermediate operations are lazy. This is very important to know for interview also, because these are lazy means they do not perform any processing until a terminal operation is invoked. So lambda expression has stream pipeline has three parts, right? Source, intermediate operation, and terminal operation. So until a terminal operation is invoked, these intermediate operations are not invoked actually. They won't process actually. So those are lazy. So this is one advantage we can say to improve the performance. So what are the examples? Few examples are map, filter, distinct, sorted, limit, and skip. These are all intermediate operations. They won't perform immediately, but after they will be executed once a terminal operation is invoked. Okay, we will see that in a while. So what is a terminal operation? Terminal operations produce a result or side effect from a stream. So this is actually producing a result. Okay, they consume the elements of the stream and trigger the execution of the stream processing pipeline. Okay, once a terminal operation is invoked, no further elements can be processed in the stream. So this is the final step in the stream pipeline. Terminal operations are eager. Immediately they will be executed, not like intermediate operations, meaning they will be executed immediately when invoked. Examples of terminal operations include for each, collect, reduce, count, min, max, any match, all match, none match. We will see all this in practice. Okay. First we will start with some commonly used intermediate operations. Let's say filter, map, flat map, distinct, sorted, limit, skip, peek. So these are all we will understand, we will see practically now in this video only. And also terminal operations also we will go through. For each, to array, reduce, collect, min, max, count, any match, all match, none match. So all this we will go through one by one in this video. Okay, I would like to introduce all these methods to you, because in functional programming generally we use all these things, all these operations, intermediate and terminal operations, using Stream API. Okay, now what we'll start with Stream API. Normally we'll take a collection. I would like to take one example. Where is that? Yes. So I have already collected few examples for you for demonstrating purpose to save some time. Yeah. So let's copy this. Yeah. So if you see this, we have a list. Okay, we have a list of string objects. Those are fruits. So we may get different types of requirements in real-time projects, right? So to process this list, once we get from the database, let's say I have a requirement. I have a requirement of find the objects or find fruits which have whose length is, we can say whose length is 5 characters, let's say. That's it. This is my requirement. So we have so many fruits, right? I mean 6 fruits, right? So we have to filter out for fruits which are having 5 characters in length. Okay. Well, how you can do is, so in list interface, a method called stream is added from 1.8. So using that Stream API, that is nothing but we are calling it as Stream API. So using the Stream API, we will do it. How we can do it is stream. So we have to call stream first on collection objects, not only on list, on set or map also we use stream method only. Dot. So after stream method, we will have, so it is generating a stream now. So what is the source for the stream API? Stream pipeline. Fruits is the source. So we are generating stream. So stream itself is an intermediate operation. Okay. So stream we are generating. So we have so many methods here. These are all intermediate operations, and we may have some terminal operations also. So all intermediate and terminal operations we will have in this. So I want to take one more intermediate operation. One intermediate operation I want to take, that is I want to filter, right? So we have a filter method. So this is what I want to demo you. First I want to start with filter. Okay. Yeah. So filter, what this filter takes, we will see. We will just open it and see. So filter takes predicate. So in the previous video we learned, right? Please, I request you to go through my previous video, which was the introduction to functional programming. There we covered what is predicate. Okay. So predicate we can take. So this predicate, it is accepting, right, filter. So we need to pass a behavior for this predicate. That means the implementation for this predicate in the form of lambda expression. As we know, predicate, what it will contain, it will contain a test method which will accept some type, and it will always return boolean. So we have to return boolean always. Okay. So actually here what it accepts is collection object only it will accept. That means the objects which are in the collection, one by one it will pass to that lambda expression, and it will evaluate whether it is true or false. So we want to check the length, right? So what we will do is we have to pass the predicate, right? That means the lambda expression for the predicate. So the predicate will accept only one argument, right? Let's say that is, let's say yes. Okay, maybe that is string, or let's say we can tell it as fruit. Okay, so for every fruit I want to return some logic, right? What is that? Length, right? Whether length is equals to 5 or not, we have to return the boolean value, right? So fruit dot length, that should be what? How much? It should be 5, right? That's it. So with this, what is happening? We are passing the behavior directly into the filter method. So filter is a higher order function now, right? So this is a first class citizen, right? Because we are able to pass this as an argument, right? Next, directly we can pass like this, or we can also do one thing. This one we can extract into the predicate, like how we did in our previous video, refactor, extract method, refactor, extract local variable. Okay, first we will complete this, then we will see. And dot, we need to either print it, or we need to collect into some other list. Both things we can do here. Okay, let's say I want to collect into some other list. Okay, for that we need to use one more operation, one more method called collect, and inside that again we need to call something called collectors dot to list. So it will give us, it will collect the filtered fruits into one list. Okay, so we can assign that here again. So here what we can do is we can make them into next lines. Okay, like this. So fruits, filtered fruits, let's say filtered fruits. So filtered fruits. So this one we can print and see. Yes, so only these two have length 5. So this is how we can pass the predicate expression, and we can filter out, right? So this is how you can pass the expression for predicate. So, and also instead of passing directly, if you want to reuse this expression in so many places in your code base, then we can also store this expression somewhere with some variable. Okay, let's say I will call it as predicate. So we can also do like this. Okay, otherwise I can do like this also. String, it is accepting string, right? So we can also do like this, right? So this is how we can assign. You know, right, we already learned in the previous video that this is nothing but lambda expression, which actually represents the anonymous class, right? We are actually implementing the method behavior here, right? So anyway, so this is how we can use the stream API using the stream method, and then intermediate operations, and then terminal operations. So this is a dot collect is a terminal operation. So dot filter is an intermediate operation. This is lazy. If you don't apply dot collect, then this will not be executed, remember. Can we prove that? Can we prove that? How can we prove that? What I will do is I will add some sysout here. Normally we won't do like that, but I can add some sysout here, and I can prove that without this will not be executed. This portion will not be executed. I want to demonstrate that this is lazy. Okay, what we can do is I will add one more statement here. So for multiple statements, what we have to do? So so I will do some testing. Okay, and now anyway it will be executed, right? 3 times it got executed. Oh, not 3 times, sorry. Here how many are there? 6, right? So 6 times it got executed. Now if I comment out this, so if I comment out this, actually this will return list, right? So what I will do is I will just remove this for now. That's it. Okay, I am not assigning to anything, I am just executing this portion only the intermediate operation I am executing. Okay, let me comment out this. Now let's run it. Am I getting any output? No, right? Actually I am executing filter right here with this expression, but it is not printing this test. So that means what? It is not executing this filter method itself. Awesome, right? That's why we are calling it as lazy. Intermediate operation. Filter is an intermediate operation. This is lazy. So when I apply this collect, so I will remove the semicolon here. When I apply the terminal operation, then only this will be executed, right? Then only this filter is getting executed, right? So this is the meaning of lazy. And collect is eager, immediately it will be executed. Here filter is lazy, so it will be executed whenever we execute terminal operation. Okay, this is what we need to understand. Okay, this is about stream API. It forms three parts. One is source, the second one is intermediate operations, the third one is terminal operations. Okay, and also even after filtering, we can also do, along with filter, we can also apply some more intermediate operations. We can form a chain of operations actually here. Let's say after doing that, I want to transform these strings into uppercase. Let's say for transformation purpose we use map actually. Okay, so filter is for filtering, so map is for what? Transformations, remember. So this what it will take? It will take function. Okay, it will take function. So it will take one argument, that is nothing but let's say fruit only. Here I am just representing it with yes, and what I want to do this fruit, I want to make it uppercase, right? I want to return to uppercase like this. That's it. So now it will give us uppercase version. Okay, after filtering with 5 characters, then we will get the uppercase version of the fruits. Okay, let's collect that here. List string fruits 2, let's say. Okay, so this one I can print here. So if you see this test I want to remove. Anyway, we understood, right? It is lazy. Apple, grape, right? Awesome, right? So we are able to use map for transformation purposes. And here again, whenever in the boolean, in the expressions, in lambda expressions, whenever I am calling methods like this, I would like to use I would like to use what method references. It will become more easy for me. So I would like to use method reference here. How we can use method reference? So two uppercase is existing in the string class, right? So simply on string colon colon two uppercase we can use like this. This is how also you will be seeing in the code base. Whenever you join some project, then you will be seeing this kind of code. So I am using the method reference here. This way also we can do it. Okay, so it will give the same output. Okay, so this is how we need to use the filter and map. Okay, now we will learn some other one. Flat map we will learn now. So for flat map, I will take another example. So flat map, what it will do? So I want to match, because I have a list of lists here, nested list I have, right? We have 3 lists inside a list, right? Nested list. This is called nested list. If I want to merge all these lists into single list, I want to merge all these 3 lists, independent lists, into one single list. The single list containing 1, 2, 3, 4, 5, 6, 7, 8, 9. In those situations, we use flat map. It will flatten the list. It will flattens the list actually. So that's the purpose of flat map. You may get one interview question: the difference between map and flat map. So you have to understand. Then you are able to answer. Right? Map is just for transforming the list collections, but nested list is for merging the multiple lists into single list. Right? Yes. Which are inside a list, of course. Now how can we do is again the same story. We have to start with the collection. We have to apply stream method. Then we have to apply what? Flat map we have to apply. So how to pass here again? What it is expecting? It is expecting function only here. Okay. So how to apply here? So here actually stream method we have to apply. On each list we have to apply the stream method. Then it will convert that into stream, and all the streams it will merge actually. So we have to apply the stream method on list so that it will convert into stream. So we will have 3 streams. All these 3 streams will be merged into single list, single stream actually. Then we will collect it. Okay. Here we will deal with streams. Okay. So in list we have stream method. We can use that. Then we have to collect. Okay. Collectors dot to list. That's it. So let's print the output. Definitely we should get the list of integer only, right? Single list. I'll just move it to the next line like this. We can do it. Formatting also we can do like this. It will make us easy to read, right? Yes. This is how generally we do in real-time projects. We can print the list and we can see the output. Yes. So all these 3 list elements are merged into single list. So this is the purpose of flat map. Okay. So again, after doing flat map, we can apply multiple operations on this. If you want to filter out for even numbers, you can do using filter. Again, you can apply filter like this. After doing that, again, if you want to apply some map, again you can apply map. So like this, you can apply multiple intermediate operations in the pipeline. Okay. Let's say I want to use filter for even numbers. Let's say, how can you do it? Simple. That's it, right? Now I will get only the even numbers, 2, 4, 6, 8, right? So this is how you can chain the operations again. Okay. So this is nothing but the predicate. We are providing the lambda expression for predicate, and here we are providing for the function. Okay. So this is how you need to do it. Okay. Here also, here we cannot use the method difference because we are not calling the method, right? It is just an expression, right? That is what we need to understand, right? What next? Distinct. So distinct we will understand. So distinct is used to remove the duplicate elements from the collections normally. Okay, let's say here I want to remove duplicate elements from this list. I have duplicates, right? You can see, right? 1 1 2 2, we have duplicates, right? We can remove from the list. Numbers dot, again stream, again always we start with stream only. Then what we want to do, just to directly apply distinct. Again distinct is an intermediate operation. We are dealing with now we are learning actually the intermediate operations only. So distinct is an intermediate operation. It will produce us the stream of distinct elements. Okay, now we want to collect it, right? Collect into another list. Okay, this I can collect into distinct numbers. Okay, like this. Now I can print the distinct elements. Okay, let's run it and see. Yes, we are getting the distinct numbers. Okay, so this is how you can use the distinct. Okay, okay, so these are simple numbers, but if you want to eliminate the duplicate objects, let's say in real time, let's say if you have employee objects, you have to make sure that you are overriding equals and hash code methods. Okay, for that we have a separate video to understand why we need equals and hash code methods while eliminating duplicates. Okay, so that you can check it out. Okay, yeah, for this string objects and for numbers, you don't need to do anything. It will eliminate the duplicates, but in real time objects like employee object, transaction object, student object, if you want to eliminate the duplicates, such kind of objects, then you need to override equals and hash code. That you have to remember. Okay, next is sorted. This is very important. Sorted is an intermediate operation we use for sorting purpose. Let's say here I have employee objects. I have an employee class defined here, employee ID and name. I would like to sort based on sometimes on ID, sometimes on name or combination, right? So we can sort based on different attributes. Okay, we will see that. Again we have to start the same story. After sorting we will again collect, right? So I would like to add this here, sorted employees. Okay, employees, again starting with stream only. Stream, after stream what we will do, we need to use sorted. Sorted we have two versions, sorted with comparator. So sorted, plain sorted we can use if this employee object is already implementing comparable interfaces, comparable interface. For natural sorting order we use sorted. Okay, but this employee is not not implementing comparable interface, so we will go for sorted directly. So this sorted with comparator we will use. So we need to provide the implementation for the comparator. Okay, for this. So what we can do here, comparator. So if you go to comparator, I want to show you this is a functional interface. Comparator is a functional interface. Okay, we need to provide the what method we will have here, compare method we will have. It will accept 2 arguments, right? Then it will return int, right? So we need to provide the implementation for that. How can we do it? So it is taking 2 arguments, right? So what we can do, 2 arguments will be, maybe it internally it will pass these 2 objects. So let's say e1 comma e2. Then what we have to do, we have to do e1 dot what you want to compare, name, right? Get name. This is a string object. In string already we have compare to method, and here we can do e2 dot get name. That's it, sorted. And after that you want to collect collectors dot to list. That's it. So you can print and see whether we are getting in the ascending order or not. So we will do one thing, we will iterate and we will see. Okay, so for iterating what we can do is sorter employees dot stream dot, we can use one terminal operation for each. Okay, I would like to introduce you this one also for each. So for each element we can do something. It will accept consumer will accept some argument, but it won't return anything, right? That's what we learned, right? So consumer, so for each element, let's say for each employee, I would like to print it E. That's it. Okay, we will see now. So are we getting the employee objects in the order of name A, B, D, E, John, right? We are getting, right? So these are sorted successfully. Perfect, right? Yes, we are good. Now we can simplify this one. Instead of writing like this, okay, this is basic of writing, because we know right, it is taking a function. So how to create lambda expression for function we know, but here we can simplify this. How? What we can do is we have a comparator class. In that we have one default method called comparing. So using this also we can do, but for comparing what it is expecting is, it is expecting function again, and but function for only that particular attribute what we want to sort. Let's say I want to sort only name. So what you can do is, here it will accept employee object and employee dot get name. That's it. Like this also we can do it. Okay, right, it is sorting, right, based on the name. We are only calling the name. Again we can simplify it, right, to method reference. That's it, more simplified, right? Yes. So this is how we can sort using sorted intermediate operation, and we can collect. And if you want to sort based on multiple attributes, let's say I want to sort, let's say I have same name for the two IDs. Let's say I will make it John here. If you sort it, you will get John twice, and here it is 1, here it is 5. Then after sorting by name, I want to sort based on ID also. Let's say in descending order. Okay, 5 should come first, then 1 should come next. So how we can do? So here again we can chain together. How we can chain is, after comparing we have a then comparing method. Here we can pass again employee colon get ID. So now it will sort by name first, then by ID. So, and it is naturally it is by ascending order it will do. We will get the same output. But if I want to do it in descending order, 5 should come first. Then what we can do is, here after comparing dot reversed. Okay, we will see what will happen. Now see, even these names also coming in descending order, which is not as expected, right? Yes. So we should not apply here actually. Outside of these two, comparing, then dot reversed, if we apply, it will, this dot reversed will be applied for whole. But I want to apply dot reversed for only ID, right? How can we do it? So I will remove from here. Okay, then comparing, it will take one more argument, comparator dot reverse order. So now this will apply only for ID, not for name. Okay, let's run it and see. Yes. So I am getting the names in the ascending order, and after, if you have same names, then I want to sort IDs in the descending order. That's what I am doing, right? So this is how you can chain. If you want one more, you can add one more, then comparing like this. So anyway, so this is the demonstration of sorted. So normally it is very common that in our applications definitely we will be sorting. The sorting is very common, right? So we can use functional programming like this using Stream API sorted method like this. Okay. Next. So now let's understand limit and skip. Okay. Let's take one more example. Okay. So it is very simple. We want to limit. Let's say we have 6 elements here, right? 6 objects, right? Let's say I want to limit for only first 2 objects or first 3 objects. I want to limit. Limit means I want to get only the limited number, probably from the first serially. If you take in the sequence, I want to print only the first 2 elements or first 3 elements. I want to fetch only the first 3 elements. I want to fetch only the first 2 elements. So in this case, actually we go for limit. It's very simple. As the name suggests, we have to limit it. Again, stream dot limit. Limit, we have to give how many elements you want. Let's say I want 2 only. That's it. It will give the, after limit 2, it is an intermediate operation. We have to collect it. Collect collectors dot to list. Okay, done. So we can print it. Directly I can print it. Here I will print it instead of collecting into, that is a list only. Anyway we are collecting, but that list I want to print it. Okay. Yes, apple, banana, only the first 2 I am getting, right? After limiting, again we can transform using map. You can filter using filter. So many things we can use in the pipeline. Okay, anyway, so this is for limit. So let's say I want to skip. Let's say I want to skip first 2, then remaining I want to print. How can we do that? Simple. Replace limit with skip. That's it. It will skip the first 2 elements, then remaining only it will give. Can we run it and see? Yes. See, from cherry I am getting, from the third element I am getting, right? So the first 2 are skipped. So this is the purpose of skip. Okay. So limit and skip we understood, right? Yeah. Next we will see peak. Peak is something. Okay. What we will do is, peak is something we use for debugging purpose and see what is happening for each element in the sequence. So we will understand now. Here I am doing something here, right? So let's say I want to apply peak here. So in the peak I can print this. So actually what it will take, what this peak will take, we will see. Okay, it will take consumer. Okay, so what I can do is I can do print system dot out colon println. I can do like this, right? Method reference instead of lambda expression I am using method reference here. If you apply peak like this here, what will happen we will see. Okay. So what is happening, initially internally, normally it will go through each element, right? The stream. So for each element this peak is getting executed for apple, banana, cherry, date, grape, kiwi. Then in the final output anyway we are getting this 4, but for each element this peak is getting executed. This is used for debugging purpose. Normally what is happening inside the stream, and if you apply this peak after skip 2, what will happen we will see. Okay, see, after skip we have only 4 elements, right? So for only those 4 got printed here, right? So peak is, the purpose of peak is for normally for debugging and logging purpose. Okay, when we use streams. Understand? Yes. So these are all intermediate operations we covered. Okay. So after intermediate operations, we'll go through the terminal operations now. Okay. We'll take this one example. It is already there. Now I would like to introduce you for each we already covered, right? What it will take. Let's say I want to print all this. For each, it will take the consumer, right? Yes. Fruit. Then I want to print this. Then I can happily print the fruit. Okay, let's print and see. Yes, we are able to print it, right? So for each is meant for consuming something. It will consume each element from the collection, and then if you want to do something with the for each, then you can do. Here I am just printing to the console. Okay. Yes. Next, to array. So there is one more terminal operation called to array. Using to array, we can convert a list into array. Okay. So how we can do that? I have a list, right? I want to convert into array. What we can do? So again, fruits.stream dot to array. So we need to create a new array object for each element, right? New array. See, it is we need to create an array of string objects, right? We need to create an array of string objects, right? So how we can do is, here internally we need to create an array. How we can create string array : new dot. It is a terminal operation, right? So it should give us array only, right? So actually string array, right? So that's why in this, using the string array, this is a constructor reference. We can use like this, constructor reference. For each element I'm using new operator like this to create a string array object. This is how we can create. Then we will get the array of string objects. So we can correct like this: string array str. That's it, right? So using like this, we can happily get the array of string objects. So this is one way, using the reference. Here actually we are creating the string array, right? So if you, this is a method reference, right? Okay, you don't know how it is working. If you want to use lambda expression, actually what this to array, what it will provide is, it will provide the length of the array. That means how many number here? 6, right? The 6 it will provide. So if I want to convert this into lambda expression, I can happily convert this like this: new string n. It is a terminal operation, right? It won't execute for each one at a time. It will execute this one at a time. Internally to array, what it will do is, it will actually take the length of this list, that is size of this list, that is 6. That 6 it will pass to it. Using that 6, what you are saying is, create a string array using the size as 6. So this is how we can do using the lambda expression. Okay, this is okay to understand easily, right? But if you are familiar with the method reference, very easy to do like this, using the method reference like this, constructor reference. So if you want to print this, how you can print? Yeah, for loop we can use, or stream API if you want to use using this array. Then what we can do is, I want to use stream API to print the elements. What you can do? This is an array, right? So we have arrays class, in that we have stream method, and if you pass this string array, then it will convert into stream. What it is saying? Dot stream. We need to pass the string array, right? Dot. After passing, then we can print each one, right? System dot out : println. That's it. Okay, simple. So we are able to successfully convert a list into array using the to array, which is terminal operation. So this is how we have to convert. Next we will understand reduce. This is very important. Reduce, which is a terminal operation. Reduce we generally use to do some bulk operations like summing the numbers, like for example some reduce it to single number. Let's say here if you see this, we want to reduce these numbers into a single number, that is maybe addition of the numbers or multiplying the numbers or something. Or if you have multiple objects, I want to result into a single object using some certain operations, then we use reduce method. Okay, so here I want to, let's say I want to sum all these numbers. Okay, I can use a reduce method. How I can do is numbers dot stream, after stream reduce. So reduce will normally take binary operator, we call it as accumulator. And what is this binary operator? It is nothing but which is extending a by function. So normally by function will take what? It will take 2 arguments and it will return the result, right? So reduce, for reduce we can pass 2 arguments, that is one is the initial value, because if you want to sum, if you want to accumulate, if you want to do 1 plus 2, then if it starts with 1, with before 1 more element should be there, right? That is the initial value. Then that initial value I can give it as 0. Then I can start with accumulator lambda expression here, a comma b, it will take 2 arguments, then result the sum of these 2. That's it. It will actually accumulate and it will print the addition of all these numbers. So this is how you can use the reduce method, something. Okay, so if you print this, this is actually giving the result, right? It will return something int value, right? So I can directly print that here like this. Okay, let's print. So it is giving the 15, that means it is adding all these numbers. So this is how you can use the reduce method. See, here I am introducing all types of intermediate operations and terminal operations, then you can practice more and master. Okay, then collect we have already covered, right? Yes. Then min and max. So if you have numbers, I want to get the minimum number, I want to get the maximum number, it is very simple, just to do min, but min will accept comparator. We have to provide that. Again the same comparator dot comparing, we can do like this, and you have to provide the element, right? So what you can do is the same yes, that's it. Like this you can do it, because it will provide each element, right? Yes, number, and the same number you can provide. Otherwise s dot int value also, it is nothing but an integer, right? Integer dot, otherwise you can do like this, yes, that's it. See, it is returning optional of 1, that is a optional is something we will discuss later. It is wrapped with optional object, but the minimum value is 1 we are getting. Okay, if you want to get the actual value, then you can apply get method on it, dot get, then it will give the minimum value. Okay, 1. If you want to get the maximum value, the same you can apply here, max 5 is the maximum value, right? 5 we are getting like this. So this is how we need to use the min and max. Okay, next count. If you want to count how many numbers here, 5, right? Simple. Directly you can apply the count like this. You will get the count of elements in the collection. 5 we have, right? Let's say if we have, I will add 10 here. How many we have to get? 6, right? 6. So number of objects in the collection, if you want to count, then you can actually use the count method. Okay, any match. So we will understand any match. Okay, fruits dot stream. Okay, I want to match. Okay, let's say I want to see if any fruit is having a length of 5, or I want to match is there any fruit which is equals to apple. So I want to see is there any object matching with my criteria, then it has to return true. So in that case we will use any match. Let's say any match will take the predicate, right? So we need to pass the boolean expression. So for each object, if s dot equals, let's say I want to check whether apple is there or not, or banana is there or not, date is there or not. Let's say date. That's it. It will return the boolean value. Can we print and see? So it should return true. Okay, if it is not there, let's say pineapple. Is it there in the list? Not there, right? It should return false, right? It is returning. So this is how we can use any match. So if it is matched with any of the objects, then it will return true. So one more thing is all match. It should match with all. Let's say all match means this object should match with every object, then it will return true. So in this case it will return false. So we will take one other list as an example. We will deal with numbers. I want to see whether all are even numbers or not. All are even numbers or not. Okay, what we can do here, let's say n percentile 2 equals to 0. So I want to check whether all the numbers in the given list are even numbers or not, then only it will match, right? True, because all are even numbers. For example, if I place one odd number, then it will return false, right? So all match means it should match with all the objects in the list. Okay, and none match means it should not match with anything. Let's say I want to make sure there is no odd number in the list. I want to make sure that there is no odd number in the list. So in that case I will use none match. So I want to make sure, okay, in the provided list I don't want to have any odd number. So I will check with odd number, none match. So it should return what? True. That means I am making sure that, okay, in the provided list I don't have any odd numbers, then I am using none match. So this is how you can use different types of terminal operations we have, and intermediate operations and terminal operations. So these we need to aware that, okay, Java is providing these kind of operations, these kind of methods as part of Stream API. If we are aware of this, definitely we are able to immediately recollect, okay, and immediately we can implement this in our projects to make it easier in a functional style. So as we already know the benefits of functional programming, all those benefits we can enjoy actually while doing functional programming. Okay, thanks for watching. Please subscribe and share with your friends, even to make them understand what is functional programming. And for more videos, definitely these videos will be helpful to them also. Please share the videos. Please share the information about this channel to your friends. Okay, thank you. Bye bye.